Hi, my name is Hans Lindetorp and I would like to present my PhD project for you. I call it Sound and Music Production for Interactive Media. And I would like to tell you why I'm passionate about it, what I'm doing, how I do it, and the results so far, and then also show you some projects that it has resulted in. I have been teaching music production at the Royal College of Music in Stockholm since 1996, and I've met so many talented students full of music. They sing, they play, they compose, arrange, record, and produce music, and they want to touch the world with their music, which works fine many times. They use programs like this to record the music with different tracks and instruments, and they mix it and then they publish the music through services like Spotify.
It's beginning to look a lot like Christmas,
Which works fine for normal music. But if you want to make music for games or virtual reality or interactive installations or things like that, then we have new problems. And the problems for my students is that they need to learn to program. They need to understand the logic and also often learn a language to be able to implement their music into interactive environments. And that is the challenge that I've been working with, and that led to my PhD project. What I realized was that some of my students actually knew a little bit about interactivity, and they knew it from web technologies. So some of them had actually used HTML a little bit and understood the concept of simple HTML tags. And then came Web Audio API around 8 years ago, which is a powerful audio engine built into your web browser, which could be your smartphone or your tablet or your computer, and that makes it possible to create a really advanced audio application actually straight into your browser. But it was still complicated for my students to learn the Web Audio API, so I created Web Audio XML, which is an XML layer on top of the API that comes with a friendly XML language and gives the students tool to implement sound and music into their web pages. It also uses a familiar terminology that is friendly to music producers, using words like track, region, motif, and stuff like that. And it also comes with strategies for how to make music interactive and dynamic. Let's look at an example. Imagine we have music like this, with multiple tracks. Then we can fiddle around with the arrangement in the program, so we can mute tracks, but as soon as we export the mix is static and can't be changed anymore. And so that to make it work in an interactive environment, we need to export the different instruments separately and then have a system for controlling how they should be put together. And that is what Web Audio XML is doing. So first we need to export all the audio files, and then we go to an editor where we create our web pages, and we open up the XML document containing the Web Audio XML code, and we type the name of the different files here on each track. And we can collect the different files in different arrangements. We can create a longer or more complex form of the music. We can also set different tempo and time signatures and stuff like that. When that is done, we can also go into the mixer and create a mixer with any number of channels and connect the different levels to different variables. So in this case, we have a variable called intensity, controlling the level of these gain nodes playing different sounds. And that would work similarly to a mixer where someone is moving the sliders continuously, controlled by one common variable. That can give us a result like this. I hit play and I hear the audio files play, but not all of them, but just the clavinet and the synth pad. This slider is not a position slider, but an intensity slider. So I move between different mix stages. And Web Audio XML interpolates between the different stages. So when I move from 20 to 30, we can hear the shaker fading in. Going to 40, we can hear the bass and the drums fading in. Between 50 and 60, clavinet is re-entering. And when I pass 60, then suddenly the bass changes from long notes to short notes, along with the drums. So, with settings like that, it's possible to make the music really, really dynamic and interactive. You might ask yourself, but how is this meant to be researched? They just seem to have a lot of fun. Well, I frame my research as being research through design for the art. So I use methods from research through design field. And I used the design to solve problems posed by music producers and composers. And hopefully the result of the design is also useful for the art. And this is how the iterative process usually works. So it often starts with my students having a project where they are expected to make interactive music and sound for like a web page or some other interactive environment. They have visions, they come up with ideas for their music, and often we can implement it straight away. But sometimes we need to add some features, and then we sit down and we discuss how that new features should be named, how it would feel natural to implement it and to write to get the feature they're looking for. Then I implement it into the code, and the students, they use it in their projects. And after the project is done, we evaluate the result and how it was to work with the new feature. And then I sum up and analyze the result and write papers. So that's how it's research. And to collect data, I use annotated portfolio. So I have my research diary every time I code and discuss stuff. We often run focus groups where we collect, for example, all the students from a group using the same feature and discuss the experience and new ideas coming from that. And I often run online forums for simpler questions and collecting more quantitative data. And I've built in some measuring tools into the software itself, so it can collect data about the creation the students have made. So we can, for example, count the numbers of oscillators or stereo panel nodes or whatever we'd like to investigate. So far, it has become a bit more than 10 publications, where most of them relate to this technology. And the results so far indicates that Web Audio API is a very robust platform. We built interactive music installations that had run for several months at the Nobel Prize Museum, for example. We built sensory-driven multi-user, multi-speaker instruments using the same technology. And of course, a lot of web pages with interactive audio and music. The XML language is actually fairly easy to understand for the students. So it has proven that they can achieve a much more interesting result using this syntax than earlier versions using JavaScript. We've found really useful strategies for mapping variables to audio parameters. And we found that combining Web Audio XML with an online editor like P5.js is a dream come true when it comes to teaching interactivity and sound and music, because it takes no time at all to get started, no application to install or download or anything. Also, the way we work with artistic ideas as the driving factor has led us into quite innovative solutions for example, loopings, lead-ins between different parts of the music, interludes, shorter pieces in between, and also variation over time, controlled by random factors or external variables, and also a lot of different aspects on dynamic mixing. And we've also learned that web technologies really open up for a lot of collaborations in all sorts of directions because of the nature of the technology. It's very, very open source, and a lot of technologies are accessible and available to just click into Web Audio XML. So let's look at some of those projects that it has resulted in. Here we see the funky instruments built for people with different impairments. And this is Sonify Folk, where Web Audio XML is used to map the motion from the dancers to audio parameters that makes it possible to hear the dancing. And this is from the Science Museum in Stockholm, where the user could create their own future city landscape. Control audio with your webcam with a single line of code. It has led to practicing apps where you listen and imitate. Or practicing singing microtones, often used in Swedish folk music. That was a few snapshots that have come out of the Web Audio XML project and my research. Thank you for listening, and don't hesitate to contact me if you have further questions.